Hello everybody, and welcome to the presentation for Smart Energy Management Systems and 3P Strategy. Smart Energy Management System is not simply intelligent meters, or it's not simply an hardware. It's a combination of measurement instruments, industrial data communication, and analysis software. So in this slide, we are seeing the traditional ways of measuring electrical parameters. For example, ammeter, voltmeters, kilowatt meters, power factor, or frequency meters are used. These all are being replaced by intelligent meters like these, which can measure up to 800 parameters. So here you can see in the main distribution panel, we have only simply a single color. So this is a saying from a famous scientist, Max Planck: real is what we can measure. So before going for electricity saving steps, we should measure them accurately and not simply the kilowatt hours, but also the other parameters which can affect your energy consumption. Now here in this Iceberg Analogy, we can see the effects of smart energy management system is not only the electricity cost reduction, it's the tip of the iceberg. The main reason behind this is the equipment optimization and the system reliability, means reducing the breakdowns or saving the capital investment. Now, based on our experience, if we implement the 6 steps for electricity cost savings, we can achieve up to 30% of electricity cost, and in certain cases up to 50%. Now let's see all these 6 points. The first is the kilowatt hour. We must identify the energy inefficient and where the energy is being wasted. The second is eliminate PFC penalties. PFC is power factor correction. We will come later in the presentation what is the effect of power factor correction in the electricity bills. The third point is cut down demand charges, means avoiding the peaks, the peak consumption, and controlling them. The third is optimized energy purchase with the suppliers. The fifth point is the most important point. What I see is the precise measuring in sub-billing. Means instead of a collective bill, for example, for entire universities, you have individual bills for departments, for lighting, for hostels, for example, canteens or hospitals. And based on this data, we can start the awareness programs which will make the people more sensitive about their electricity consumption. So the final summation will read as KWH plus PFC Emax cost center purchase and awareness, so that we can reach the target of 30%. So here we have an example of the inefficient motors which were being used in the famous German car manufacturer. So they have purchased electrical motors few years back, and if you see the total cost of ownership, only 1% of the cost is the purchasing price. 2% is the installation and services, and 97% is the energy consumption by the electrical motors. So it is very important when you purchase electrical equipment, you must see the total cost of ownership and not this one person means how much the equipment cost. It might be possible that equipment is very cheap, which is just 1%, but this 97%, the energy consumption is much higher. So in the end, you will be paying much more, in certain cases 2 times, 3 times in the whole lifetime of the equipment. So we have installed these intelligent meters. These intelligent meters are not simply multimeters. It's not simply ammeter, voltmeter, frequency meter. They are much more than this. They are multimeters. They measure the kWh, harmonic analyzer, transient recorders, event, Emacs. They have integrated PLCs. They can log the data. And these intelligent meters are finding a good place in the smart energy management systems. So after installing these power quality meters, data was collected for 4 months. And it was found out that the plant was using low efficiency motors. In fact, there were high efficiency motors, 89%, but we have decided that 89% is a little bit on bad side. We should go for a little bit higher efficiency. So instead of 89%, we have gone for 4% more higher motors. So we have gone for 93.8% efficiency. So in total, we are having about 4.1% more efficiency, but in terms of losses, the losses were down by 42%. In the later slide, we have more calculation sheets. So simply by changing this motor, we have saved 6,300 units per year, so which was about 567 euros or 34,000 rupees per year for a single motor. Moreover, the customer was having a new motor. So they have invested about 600 euros and they have saved about roughly 600 euros in a single year. So the return of investment was 1 year. So let's see the calculations. So the old motor was 89.7%, the losses was 2.5 kilowatts, the new motor was 93.8%, so the losses was 1.45 kilowatts. So when you see the efficiency percentage, the delta is just 4.1%, but the losses was about 42%. So you have reduced the losses roughly by 50%. So if we run about 8,760 hours in a single year, we have a saving of 1,011 euros. So the purchasing price was 600 euros, which was definitely less than the saving. So the return of investment was 1 year. So if we assume that motor will run for 10 years, so we have an earning of 9,000 euros or 5.4 lakhs in the rupees.